Have you ever pondered about the origin of the universe and how it all began? This is a question that has intrigued humanity for centuries, sparking curiosity and driving us to look towards the cosmos for answers. The most widely accepted explanation for this cosmic mystery is the Big Bang theory. Around 13.8 billion years ago, our universe was not as we know it today. Instead, it existed as a singular point, unimaginably small, incredibly hot and extremely dense. This was a state of existence so different from our current reality that it's almost beyond our comprehension. But then, in a fraction of a second, something extraordinary happened. This minuscule point began to expand. And it didn't just grow a little bit. It ballooned, inflating faster than the speed of light. This sudden, rapid expansion is what we refer to as the Big Bang. In the wake of this tremendous event, the universe transformed. The extreme heat and density gave way to a cosmos filled with particles and energy. As the universe continued to expand and cool down, these particles started to combine, forming atoms and eventually stars and galaxies. And the astounding part is, this expansion hasn't stopped. Even now, as you're listening to this, the universe continues to grow larger. The galaxies are moving away from each other, stretching the cosmic fabric. So when we talk about the birth of the universe, we're not discussing a single moment in time. Instead, it's an ongoing process, a cosmic evolution that started with the Big Bang and continues to this very day. This colossal expansion, this Big Bang, was not merely an event. It was the beginning of time, space, and reality as we know it. It was the birth of every star, every planet, every grain of sand, and every living creature in the universe. This explosive moment set the stage for everything that exists today. And as we delve deeper into the mysteries of the cosmos, we come to realize that we, too, are a part of this magnificent cosmic story. So, following this colossal explosion, how did we end up with the galaxies we observe today? Well, imagine the universe as a colossal theatre, and the curtain just rose on the grandest performance of all time. The stage was set by the Big Bang, the universe's fiery debut around 13.8 billion years ago. But our story really begins some 400 million years later, a blink of an eye in cosmic terms. In this early cosmic era, the universe was a dark and formless void, filled with clouds of hydrogen gas and dust. Now gravity, that ever-present cosmic architect, began to weave its magic. It started pulling these clouds together, condensing them into dense pockets. These pockets grew hotter and denser, until finally they ignited. The first stars were born, pinpricks of light piercing the cosmic darkness. But the universe wasn't satisfied with just stars. These stars began to clump together, drawn by the same gravitational forces. They formed clusters, then galaxies, vast spinning islands of stars. Each galaxy a unique masterpiece, some spiral, some elliptical, others irregular. Our own Milky Way galaxy, a splendid spiral, was one of these early formations, taking shape around 13.6 billion years ago. It's a vast cosmic neighborhood, home to hundreds of billions of stars and an untold number of planets, asteroids, and comets. And here's a mind-boggling fact. There are as many galaxies in the observable universe as there are stars in the Milky Way. Each of these galaxies teeming with stars, with planets, with potential, each a testament to the power of gravity, the pull of the cosmos, the beauty of creation. So the galaxies we observe today, including our own Milky Way, are the result of a cosmic ballet choreographed by gravity over billions of years. They are the descendants of those first clouds of gas and dust, shaped by forces set in motion at the dawn of time. This was the birth of galaxies, vast cosmic neighborhoods, one of which we call home. From the broad expanse of galaxies, let's narrow our focus to the creation of our own solar system. Around 4.6 billion years ago, a colossal spinning cloud of gas and dust, known as the solar nebula, dominated the space that would eventually become our solar system. This nebula was part of the aftermath of a supernova explosion, a stellar event so powerful that it could scatter elements across the universe. The nebula, under the relentless grip of gravity, began to collapse inward, its material drawn to the center, forming a flat, spinning disk. At the heart of this disk, where most of the material congregated, a protostar began to form. As the protostar accumulated more and more matter, the pressure and temperature at its core escalated, triggering nuclear fusion. This marked the birth of our sun. But the story doesn't end there. The remaining material orbiting around the young sun began to coalesce into small, solid bodies known as planetesimals. Through a process called accretion, these planetesimals collided and fused, gradually growing larger and forming protoplanets. The inner solar system, where temperatures were too high for volatile compounds to condense, saw the formation of rocky planets, including Earth. The outer solar system, where it was cooler, saw the birth of gas giants, massive planets composed primarily of hydrogen and helium. Over time, these planets cleared their orbits of debris, marking the end of the planet formation phase. The solar wind from the sun blew away the leftover gas, leaving behind a system of planets, dwarf planets, asteroids and comets orbiting around a central star. The creation of our solar system was a complex and tumultuous process. From a vast spinning cloud of gas and dust, gravity and time fashioned an array of celestial bodies, each with its unique characteristics and history. And so, our solar system, a tiny part of the Milky Way galaxy, was born. In the midst of all these cosmic events, the Earth made its debut. Picture this: a swirling cloud of dust and gas, remnants from the formation of our sun, a scene of chaos and intense heat. This was the birthplace of our planet Earth, around 4.5 billion years ago. The Earth didn't magically appear in its current form. No, it started as a scorching, molten mass, a fiery ball in the depths of space. The outer regions of this mass began to cool down, a process not dissimilar to how a hot cup of tea gradually loses its heat when left untouched. This cooling led to the formation of a solid crust on the surface, the first vestiges of what would become our continents and ocean floors. But don't be fooled by the term solid. This early crust was unstable, constantly reshaping and reforming due to the extreme heat and pressure beneath it. Ever heard of the term living planet? This is why. Our Earth was, and still is, always changing, always evolving. Throughout this period of intense heat and constant change, heavier elements like iron and nickel sank towards the center, forming the Earth's core. The lighter elements, on the other hand, rose to form the mantle and the crust. This process, known as differentiation, gave our Earth its layered structure: the core, the mantle, and the crust. The Earth's early years were not easy. Bombarded by asteroids and comets, it was a harsh, unforgiving place. But it was these very impacts that brought water to our planet, filling our oceans and creating the necessary conditions for life to eventually emerge. The formation of the Earth, from a hot, molten mass to a solid planet, was a process of constant change and adaptation, a testament to the dynamic nature of our universe. It was a journey of billions of years, shaped by cosmic events beyond our comprehension. This marked the beginning of the Earth as we know it, a beginning that set the stage for the incredible story of life, evolution, and our own existence to unfold. A story that we are still discovering, still piecing together, as we continue to explore the vast expanse of our universe. From the Big Bang to the birth of Earth, we've journeyed through billions of years of cosmic history. We started with what scientists believe to be the beginning of everything, the Big Bang. Around 14 billion years ago, a singularity exploded, a point of infinite density and infinitesimal size. This colossal explosion gave birth to space and time, and the universe as we know it began to expand and cool. From this primordial soup of energy, matter began to form. As the universe cooled, particles bound together to form atoms. These atoms, primarily hydrogen and helium, were the building blocks of the universe. Over billions of years, gravity pulled these atoms into clouds of gas and dust. These clouds became the nurseries for the first galaxies. We then transitioned to the formation of galaxies, these colossal structures of stars, gas and dust, bound together by gravity. Within these galaxies, billions of stars were born, lived and died. Their deaths, in massive explosions called supernovae, seeded the universe with the heavier elements necessary for life as we know it. Next, we explored the creation of our own solar system. About 4.5 billion years ago, a cloud of gas and dust in our galaxy collapsed under its own gravity. This collapse sparked the birth of our sun, and the remaining material began to form the planets, including our own Earth. Finally, we examined the formation of Earth. Over hundreds of millions of years, our planet cooled, volcanoes spewed out gases to form the atmosphere, and water vapor condensed to form the oceans. It's a complex and fascinating process that has shaped the world we inhabit today. Each phase of this cosmic journey is a testament to the incredible forces and complex processes that govern our universe. They remind us of our place in the cosmos, a small blue dot in the vast expanse of space. The next time you look up at the night sky, remember the cosmic journey that led to the creation of our home, the Earth.